Okay, so here's our first video of the year for Unit 7, Lesson 1, Relations and Functions. So our learning targets. I can define a function and I can determine if a relation is a function. So a couple definitions so we can figure those out. A relation, it's a pairing of inputs and outputs. Okay? And whenever we have inputs, we're going to think of x values, and outputs are going to be y values all the time. So a relation could be an ordered pair. 2, 3. That's a relation. We're going to show you some other relations. But now a function is a special type of relation in which each input, so x value, is paired with exactly one output or y value. So a function is a special relation in which each input is paired with exactly one output. All functions are relations. All relations are not functions. So keep that in mind. So a couple different ways to represent relations. We can do it, there's 4 different ways. There's list, table, graph, and mapping diagram. So lists are just like ordered pairs. A list of ordered pairs. -2, 2, -2, -2, and so on. Table, an XY table. So here's your x values, here's your y values. When you have x is -2, y is 2. Corresponds to these ordered pairs. You just put them in a table. This is all the same information. When you graph, you can graph these ordered pairs. So -2, 2. -2, -2. So we could graph them. And then a mapping diagram, so we haven't done that, but that's just we're going to list all of our inputs or our x values and then our y values and outputs. So when we have an input, when I put in -2, what do I get? Well, -2 gives me -2 right here. -2 also gives me a +2. 0, when I give me 0, it maps to 1. It maps to 1. That's how we say that. And 3 maps to 1 also. A couple things about mapping diagrams. On the inputs, we want to list them from least to greatest. So I'm going to list -2, 0, 3. Notice I don't have to write -2 twice. I can only write it once. I only have to write it once. And then we can list these in order, or we don't have to. We just want to make sure that it's mapped correctly. So -2 maps to -2, -2 also maps to 2. Alright, let's try one. So represent each relation in 4 different ways. They're going to give us one of the ways. They gave us a table. So if they gave me this table, I can make my list of ordered pairs. 3, 2. Remember, ordered pairs are x and a y. So that's 3, 2. -1, 0. -2, -1. -2, 1. 0, 3. So that's just my ordered pairs. I got that right off of the table. When x is 3, y is 2. It's an ordered pair. I can graph it also. So when x is 3, I look at 3, and I go up to 2 for y, y, y. When x is -1, y is 0. Ordered pair. X is -2, y is -1. When x is -2, y is also 1. When x is 0, y is 3. So that's a graph. I'm just going to plot all those ordered pairs. Mapping diagram. We're going to draw our inputs, our x's, and our outputs, our y's. So let's list our inputs from least to greatest. So I can look at the ordered pairs or the list right here. So what's the smallest number? -2. I have -2 again. I only have to list it once. Then I have -1. Then I have 0. And then I have 3. So I can list these in order also if I want. -1, 0, 1, 2, 3. I'm just going to list all my y's. So now I'm just going to go back to the table or the ordered pairs. 3. When I'm at 3, that maps to 2. So I draw an arrow from my input of 3 to my output of 2. Arrow goes to the right. So I map 3 to 2. Negative 1. Negative 1 maps to 0. Straight across here, little arrow. When I'm at negative 1, it maps to 0. Negative 2. Negative 2 maps to negative 1. My input of negative 2 gives me an output of negative 1. All 4 of these things mean the same thing. Negative 2, that second one right there, also maps to 1. So I'm going to draw an arrow from negative 2 down to 1. And finally 0. 0 maps to 3. When I have 0 as an input, I get 3 as an output. This means 0 maps to 3. 0 as an input, 3 as an output. So mapping diagrams, these are going to be key. We got to know how to do those. So there's a couple you tries here. You can do those at home and come up with some questions. So we can also identify functions from a list. So once again, is each input or x value paired with exactly one output y value? Important definition, you're going to have to know that. So determine if each list is a function. Explain your reasoning. So here's a list of ordered pairs. Is that a function? Well, does every input have exactly one output? So when I'm at negative 5, it gives me 4. Negative 5 has 4. Is there any other negative 5s? No. Negative 1. X value of negative 1 gives me 0. Any other x values of negative 1? No. 3. When I'm at 3, it gives me negative 1. This one here, when I'm at 3, also gives me negative 2. So no. Not a function. Why? 3 is paired with both negative 1 and negative 2. Sometimes I'm going to draw a quick mapping diagram. Negative 5, negative 1, and 3 are my inputs. My outputs, I can just list them in order for how they come here. 4, 0, negative 1, negative 2. Well, I'm at negative 5, goes to 4. I'm at 1, it goes to 0. When I'm at 3, it goes to negative 1. When I'm at 3, it also goes to negative 2. So sometimes a mapping diagram is easier to see if you have a choice. If it branches off from an input, an x, it gives you a choice. When I'm at 3, I have a choice of going to negative 1 or 2. So that means it's not an input. Okay, if you ever see this in a mapping diagram like this, you have a choice from an input to the outputs y. It's not a function. So there is a you try. You could try that at home and come up with some questions. Once again, we're going to look at those x values. When the x values repeat, it's not going to be a function. So we can also identify functions from mapping, from a mapping diagram. Is each input x value paired with exactly one output y value? Same definition. So, do I have any choices when I'm here? Negative 3 gets mapped to 2. It's the only thing. When I'm at negative 1, I go directly over to 3. When I'm at 2, I go to negative 4. When I'm at 4, I go to negative 4. So this is a function, yes. Each input is paired with exactly one output. Now you might be concerned about this, that they're both mapped to negative 4, but each input, there's no choices over here from the input. If you're at 2, you go to negative 4. If you're at 4, you go to negative 4. Each input has exactly one output. Okay? And if it's the other way around, for instance, a different example, if I was going to map 1 2, and 3. Well, if 1 gets mapped here, and 1 gets mapped to 3 also, that's not a function because I have a choice here. This would be like an ordered pair of 1, 2, and 1, 3. Those x values are repeating, so not a function. No. Okay, so there's a you try. You guys can try that one. Come up with some questions for tomorrow. Okay, we can also identify a function from a graph. So, for a graph, we're going to use what's called the vertical line test. So the vertical line test, a graph represents a function if and only if a vertical line passes through the graph only one time. So we have this graph. This blue graph here is a parabola that U-shaped. If I draw a vertical line like that red line, it passes only one time. No matter where I drew. If I drew a vertical line right here, it would still only pass through that graph one time. So this is a function. Why is it a function? A vertical line passes through the graph only once or one time. So if it passes through one time, it's a function. It's not a function if that vertical line passes through that graph twice. So I get two intersections right there on this graph. It's like that parabola that's turned sideways. Not a function. Why? Because a vertical line passes through the graph twice, or because it fails the vertical line test. That's why this is not a function. This is a function because it passes the vertical line test. And once again, if you think about this, this is an x coordinate. You could write this ordered pair. It would be 1, comma, looks like it's between 1, 2, 3, say 3.5 or something, and this one here, oops, I'm sorry, it's 2, and this would be 2, comma, negative 2. So once again, I got those x values that repeat. That's why it's not a function. Vertical line test tells you just graphically, visually, if it isn't or not. So there's about 4 different U tries down here. Just want to say one thing about this one with these, just the ordered pairs that are plotted. You're just going to look. If your pen is like a vertical line. So if I drew a vertical line through that point right there, does it hit any other point? No. Just check each point. So you're basically looking if that point is right underneath. If not, it would pass the vertical line test. Okay. The last page. So determine if each of the following pairings, so pairings, just like a relation, it could be relations, are functions. So are these pairings, these relations, functions? Explain your reasoning. So you and your social security number. Sometimes easier to draw a map. U, SSN, your social security number. So you have exactly one social security number. So yes, this is a function. Yes, and it says explain your reasoning why you have only one social security number. We're not talking about criminals that have more than one social security number. So you have exactly one social security number, so that is a function. So functions aren't necessarily all x's and y's. We can put some real examples in there. So what about you in your classes? So here's you. We're going to draw. You got math. You got English. Maybe you have history, something else, but you definitely have a math class. You definitely have an English class. Well, right there, I'm mapping. I got a choice from an input to an output. I don't have exactly one output. I have math and I have English. So no, not a function. Why? You have multiple classes. Or if you want to do the math definition, why is your reasoning? Because each input does not have exactly one output. You have a math class and an English class, not a function. Here is a function. You have exactly one social security number. Okay. 15, want to talk about real quick. A teacher makes a table, number of boys and girls. So here's the number of boys. Here's the number of girls. And what we want to do is here, just make up some examples. If you can find one example where it's not a function, where each input doesn't have exactly one output, then it's not a function. You just have to find one counterexample. So let's say I had a class of 12 boys, and in that class there was 10 girls. Let's say one of my other classes, I have 12 boys and there's 15 girls. Well, from this table, these are x values, inputs, these are outputs. I'm repeating my x values, so it's not a function. No. Why? You could have the same amount of boys in two classes but different amounts of girls. So one example proves it wrong. So no, not a function. So a couple more you tries. And what we want to try and start doing after we watch these videos, fill out this little section really quick. After watching this video, what can you do after you watch this? Can you do those learning targets? After watching this video, I still don't know how to. Well, list if you don't know how to do something. And then to help myself, we rewatch the video, ask a friend, ask a question, go to the MRC, schedule an appointment for intervention, or search the topic on the internet or something else. Circle all that apply. All right, we'll see you tomorrow in class.